Well, hey everyone, welcome to section 2.4 about Venn diagrams. Our objective today is SWBA. Students will be able to draw, complete, and interpret Venn diagrams. So draw, complete, and interpret Venn diagrams. So we have Venn diagrams. You might have seen these before, especially in maybe an English class. It's a visual way of displaying the relationships between two sets, okay? Now, you might have seen them as kind of a tool to compare and contrast before, okay? So you're comparing information or contrasting information between two different sets. So in English class, that might be between this story and another story, or two characters in a story, or different things like that. Now we have three different main types of Venn diagrams. So the first type on the far left here is all, always, and every, okay? Those are some key words you'll see that'll help us know which one's which. So one way to think about this is this our if P then Q, okay? Our if P then Q that we talked about in section 2.3 would be this kind of Venn diagram. So it's saying all elements of P are elements of Q. An element is just a fancy word for saying it is in P and it is in Q, okay? So if something is in P, it means it's also in Q. And as you can see here, the circle of P is inside of the circle of Q. So it visually represents the same thing, saying, hey, if it's part of P, it's also part of Q, but not necessarily the other way around. Next category in the middle here is some or sometimes. So the circles have a little bit of overlap. First one, P was entirely inside of Q, but this one they have overlap. So the top here, this whole section here is covering the entire thing, and this is what's made up of P or Q. If you recall, the V-looking compound statement is our OR. Now for OR, just one has to be true, or both. So you see all of where P is true, all of where Q is true, including all of where both are true. So the P or Q would include all of that. Whereas just this sliver in the middle where they both overlap would be where P and Q are at. Remember, this looks like an A, it's our and, A for and. So this is where the overlap, where they both exist. So some elements of P are elements of Q. Might be a way you would hear that with the word some. So some of this are also elements of this, so some of both. Then, in our last one, we have our never, no, or none. There's no overlap of these circles. They are entirely different. There's no relationship between P and Q. They're entirely separate. So let's look at some examples of these. So we look at right below here. We have draw a Venn diagram to represent each statement. First one, some students who take chorus also take band. So a keyword here is going to be some. Keyword there is going to be some students. So we see some, we can say, okay, well, from our previous slide, we know we're going to have an overlap, okay? So we know we're going to have some sort of overlap. So now we have to figure out what are the different categories. Well, we're talking about students who take chorus and band. So some students take chorus, that can be our first one, and they also take band. So this is displaying that there are many students who take chorus on the left, many students who take band on the right, but there's an overlap that some of them who take chorus also take band. You could also say that some who take band also take chorus, that both would be true. Second one, no perfect squares are prime numbers. Once again, no is our key word there, so they're going to be separate circles. First one would be our perfect squares. Second one would be prime numbers. And if you want to write it inside the circle, you definitely can when you have room. Probably I could have written the first one inside the circle as well. So they're completely separate. Perfect squares and prime numbers, you can be one or the other, but you can't be both. Number 3, numbers divisible by 6 are always divisible by 3. So we have an always. So we're going to have one circle inside of another. Okay, so the always is key there. So numbers divisible by 6 are always divisible by 3. So which one is which? Well, divisible by 6 is going to be our inside one. And notice I kind of ended up having to write it outside just because my circle's small enough on the inside there. So I had to write it out and then draw the arrow to say it's in. And inside we're going to have the ones that are divisible, or I can just put div for divisible, by 3. So it's saying that, hey, just because a number is divisible by 3 doesn't mean it's divisible by 6, but every number that's divisible by 6 is divisible by 3. This one we have another every. So we see every here on number 4. So that's another one just like number 3, where a circle is going to be inside another circle. Every natural number is a whole number. So we have the whole numbers out here in the big circle, and then the natural numbers inside the circle, inside the smaller circle, excuse me. Whole numbers and natural numbers, and we made those plural there. So we recall natural numbers are the numbers we count with, so 1, 2, 3, 4, 5, continuing on positive. Whole numbers are all of those, but we also include 0. 5, some, once again that's the key word, some vertical angles, it means we're going to have an overlap here. Vertical angles are complementary. So one of these we'd be talking about the vertical angles, and then we're talking about complementary angles. So there is a time when they can be both, and it's when the vertical angles are 45 degrees and 45 degrees, so they add up to 90, which means they're complementary. 6, irrational numbers are never rational numbers. That means that there's going to be no overlap, they are completely separate. One of these is our irrational numbers, and the other one is the rational numbers. They're completely different categories. Continue on, now we're going to practice shading the region. So on number 7 here at the bottom left of the page, shade the indicated region on the Venn diagram. So you see we have P and a Q with some overlap on each of these. On 7 we're talking about where Q is true. Well, Q exists here, but Q also exists in here in the middle. That's where both of them exist, so Q exists. So Q is all of this circle for Q. It's not over here though, nope. Not over there. On 8, P and Q. Don't forget this is the and symbol in between those two because it looks like the A there, okay? So they exist where both of them exist. So this is just saying where are both P and Q at? Well, they exist right here in this overlap. Nowhere else but that overlap. If we flip our page number 9, P or Q, we're saying, hey, where is P at or where is Q at or where are both of them at? So it becomes the entire Venn diagram. This we're saying P and not Q. So we're getting a little specific here, okay? Where is P at, but also not Q? So we don't want any of Q, but we want P. So we want P and things that are not in Q. So we have to do this part here. We can't do this middle section here because Q exists here, and we're specifically asking for not Q. So we have to take that middle section away. So it's just that part of P. Below this, we're going to describe these diagrams using conditional or compound statement. Okay. Another way you could do this actually, that I might even prefer, rather than using a conditional or compound statement, is using our words like our all, every, some, sometimes, no, never, like we did on the previous page. We're actually going to stick to that. I'm going to call an audible there. An audible is just a slight change. So this one, I would say that, well, the angles that measure 60 degrees are inside of acute angles. All angles that are 60 degrees are acute. I would say that that accurately describes it. And if you wanted, you could even draw the Venn diagram from my written description there. And you should get the exact diagram that's to the left. Here we have dogs, one of my favorite animals. You know I love doggos. And beagles. Okay, well, all beagles are dogs. Or doggos if you want. You'd also say every beagle is a dog. If you wanted, you could use the word every. Okay. Here, volleyball and piano. And notice this overlap here is important. Okay? Some people play volleyball. And take piano lessons. So we're interested in the people that do both. The and there. Notice my word and is important. And is important there, okay? Let me even highlight it in a different color. And is important because we're talking about just the overlap here, okay? Continuing on. 14, months with 31 days, but you can tell the shaded part does not include anything with months that start with J. So we could say the months with 31 days that don't start with J. So we want all the months with 31 days, but we don't want any that start with J because that's not what's highlighted here. Once again, if somebody were to try and draw the Venn diagram based upon my written description, it should be able to, they should be able to get this exact diagram with the shading and everything. So that can be kind of an indication on whether or not we're writing these correctly. On 15, we have two separate diagrams, one with art class, or these separate circles that overlap, one for students in art class and one for students that are freshmen. Notice here we only have the freshman part highlighted. We don't want any students that are in art class for this example. So we can say freshmen that aren't or are not in art class. Freshmen that are not in an art class. That would accurately describe what's happening here. Here we want multiples of 7 and even numbers, but we want or either one of them. So we can say numbers that are multiples of 7 or even. We don't care which one they are. As long as they're one of them, they fit into the shaded regions here because the entire thing is shaded. Now, by the way, as you go through these notes, if you need a second to pause, if you need a second to go back, feel free to do that. If you need to speed up a little bit, feel free to do that as well. And don't be afraid to pause it, try it on your own, and then go back and see what I did, okay? Continuing on to our next page, we're going to practice these Venn diagrams, practice interpreting them. So this Venn diagram here on number 1 shows the number of senior boys who play football or wrestle. And you might notice there's also a number out here. Those are other senior boys that do neither. So they still fit in this broad category of senior boys, this big rectangle there, but they don't play football or wrestle, okay? So they're in their own category over here, just so we know what that is. So our first question is, how many senior boys play football and wrestle? The word and is important. So we want ones that do both. So for that, we're just going to be looking at 9, because that's our overlap. That's where both exist. For our next one here, how many senior boys play football but do not wrestle? So we want football without wrestling. So we're going to be looking at just this 18 here that fit only in the football category but not in the wrestling category. How many senior boys play football or wrestle? So we want the total of these. So we have to add all 3 of these numbers because this is just football, this is both, and this is just wrestling. So 18 plus 9 plus 12. That's going to be 39 senior boys that play football or wrestle. And the wording on each of these is important. And then how many senior boys wrestle? Well, you might be inclined to say 12 because we see it right there. But these 9 that do both are included in that. So how many wrestle? You have to say 9 plus 2 and get 91. Continuing on to the next one. Once again, if you want to try it on your own, feel free to pause it and do that. This Venn diagram shows a number of people at the gym signed up for yoga or aerobics class. Once again, here's the just yoga, here's the both, here's just aerobics, and here are those people at the gym that are not signed up for either class, because there could be people at the gym not signed up for these classes as well. How many people are signed up for the yoga class? It's not just 68. We also have to have the 24, and then we get 92. How many people are signed up for yoga or aerobics? So we want the entire overlap, 68 plus 24 plus the 89. Well, we could take the 92 we added earlier, because that was 68 plus 24, and then add 89 to that. So we'd get 181. So 181. Next, how many people are signed up for aerobics but not yoga? Well, these 89 are signed up for only aerobics. These 24 are signed up for both, so we don't want them. So we just want the 89. Use that, but not is important. So we have the or in the second one, and then the but not in C. That was important. How many people belong to the gym? You might be just wanting to say, oh, 575. But those are just the people that belong to the gym that are not in a class. You might be wondering to say, oh, it's 181 again. But those are the ones that are just taking the class. So we need to add that 181 from these three groups as well as the 575. So 181 plus 575 gives us 756. On to the third example. This Venn diagram shows the number of 8th grade students who have a smartphone and tablet, as well as those that have neither. How many students have a smartphone and a tablet? We're looking at the overlap, so that's 58. So, and again, the overlap, 58. How many students do not have a smartphone or tablet? They have neither. That's the 117 down there that we're looking at. Next, how many 8th grade students are there? So we're going to add all the categories because these are all in 8th grade. So 116 plus 58 plus 29 plus 117. Feel free to do the math on that one. It ends up being 320. How many students have a tablet? Once again, might be inclined to say 29, but it's 29 plus 58 because they have a tablet as well. So it ends up being 87 students. How many students have a smartphone but not a tablet? So just smartphone, 116, because these 58 have both, so we don't want them right now. We just have 116. Number 4, the Venn diagram shows the number of sophomores with Facebook, Twitter, and Instagram accounts. And then we also have these 28 with none of the accounts. So this is a 3-part Venn diagram, so we have more overlap here. So let's talk about interpreting this. So this 124 only have Facebook. These 37 have both Facebook and Twitter, but not Instagram. These 46 just have Twitter. These 16 have Twitter and Instagram, but not Facebook. These 34 only have Instagram. These 55 have Instagram and Facebook, but not Twitter. And these 21 have all 3 social medias, platforms that we're talking about for Facebook, Twitter, and Instagram. How many sophomores just have a Facebook account? That'd be the 124 that are in Facebook, but no other circle. How many sophomores, once again, just have was important there. Letter B, how many sophomores have a Twitter or Instagram? So Twitter or Instagram. So we want all of this, but we also want all of these. Because everyone in these 6 different number spots, the 46, 16, 34, 55, 21, and 37, all have Twitter or Instagram at the very least. Okay, they might have more, but they have at least those 2, or at least one of those 2. So that would end up being 209 if we add all 6 of those numbers together. What you can think about it is Twitter or Instagram, so you have to circle all of Twitter. So if it's inside this circle, we count it. So circle all of Instagram, so if it's inside this circle, we count it. So if it's inside either one of those circles, we have to add them. How many sophomores have Facebook, Twitter, and Instagram accounts? We want all 3, so that's going to be our 21. D, how many students do not have a Twitter account? So we want everything that's outside of the circle this time. We want everything that's outside of the circle. So what's outside of the circle? 124, 55, 34, and this 28. We can't forget about that. So how many students do not have a Twitter account? Well, that ends up being 241. Letter E, how many students do not have a Facebook and Instagram account? They don't have Facebook and Instagram, so they can have neither. Excuse me. It's not that they have neither, it's that they just don't have both. They just don't have both, okay? So it's not the and. So any of them that don't have both Instagram and Facebook. So the overlap of Instagram and Facebook are the 55 and 21. So we want every single category except for that. So we want our 124, we want our 37, 46, 16, 34, and 28. Because those are the ones that don't have both Instagram and Facebook. So they can have them separately. They can have neither, but we don't want them to have both right now for this category. So we're looking at 285 if we were to add all those numbers up, those 6 numbers. Next, last page of the notes. Number 5, another 3-part Venn diagram, trying these out. So this shows survey results of cities visited by a group of people on a recent trip to Europe. So whether they went to Paris, London, Dublin, all 3, or neither. How many people visited Dublin or London? So we want the Dublin circle and the London circle and everything inside those because it's or. So if we add up all of those numbers, we get 327. Next, we want how many people visited London and Paris. London and Paris, so just the overlap of London and Paris. 64 plus 24 makes 88 because the word and there is key. Letter C, how many people visited London or Paris? I want the circle of London as well as the circle of Paris, but don't count numbers twice. We don't count 64 and 24 twice, and we end up getting 346. Next, how many people visited Dublin and not London? Not London. So Dublin, but not London. So we want all of Dublin. That doesn't include London, so we have to kind of do a little dip there and kind of make a little moon almost, because we don't want to include London in this. So we just have 43 plus 76 gives us 119. Letter E, how many people only visited Dublin? 76, only visited Dublin. They didn't go anywhere else. Letter F, how many people visited Dublin and Paris? So in the overlap of Dublin and Paris, because and is where they're both true. 43 plus 24 gives us 67. Letter G, how many people visited all 3 cities? Just these 24, the second funniest number. Letter H, how many people visited London? It's this entire circle, so you have to add all 4 of those numbers. Get 208. Last but not least, letter I, how many people took the survey? You have to add every single number up you see, including the 78. You add all those up, you get 500 people that took this survey. Our last problem, on a recent trip to Cedar Point, the amusement park, talking about roller coasters. So talking about asking students which roller coasters they rode, or if they didn't ride any over here at 12. How many students just went on the Maverick? Nothing else? 27. So just the Maverick, okay? How many students went on the Blue Streak or the Millennium Force? We want all of Blue Streak as well as all of Millennium Force because this is where either one is true. So add up 24, 10, 21, 14, 8, 38, and 19. We add all those up, we get 126. Letter C, how many students went on the Millennium Force and the Maverick? So we want the overlap of the Millennium Force and the Maverick. So that would be 14 and 19. So that would be 33. We're looking at the and there. Letter D, how many students went on the Blue Streak? So it's only talking about the Blue Streak, but we want any of them that went on the Blue Streak because we're not concerned that they went only on it. So add up those 4 numbers together, and we get 69 students that did that. Continuing on, letter E, how many students went on the Blue Streak and Maverick, but not the Millennium Force? We want the Blue Streak and the Maverick, but you don't want the Millennium Force, and they have to do both the Blue Streak and the Maverick. So these are the students that went on both the Blue Streak and the Maverick. We would say, well, we don't want those that rode on the Millennium Force as well. So I end up really just getting just these 10. And I cut off the line for that a little bit. So these are the notes. Please look on Google Classroom if you're not in person for any additions to the homework assignment or anything I changed to it. If you were in person, you watched this video in class, or you already got the homework in class today, that's awesome. Please go to that homework now and do the section 2.4 homework over Venn diagrams. Because I am mean, there are no don't do's. There are 15 problems front and back, although 15 is one of those part A through I problems. And if you have any trouble, don't hesitate to ask me with these, or feel free to go watch the video again, replay anything, or look back at your notes while you're working on homework. Have a great day.